This time we're going to do average pooling, I think. Not average pooling, max pooling. I can't remember what I was doing. Okay, what was I? Oh, there's something else I remember that we need to do. A little bit of housekeeping. Index map create scale 2D, that should not be using the scale length because the index could be three-dimensional. Result dot shape width times result dot shape height. Here we're only taking the two-dimensional slice because the shape could be three-dimensional. We don't know, so you have to make sure we know which one we're doing. Scale 2D or scale 3D. Let's just rename that one. What am I doing? Why is it copy? Why did it copy? I don't know. Okay, scale 3D. Okay, scale 3D takes the full 3D. Scale 2D takes the adjusted 2D version. Okay, let's put it up here. Scale 3D, three-dimensional. Should I call this zoom 3D? I don't know. There's really no reason to do that. Okay, it's three-dimensional, but we should at least make it clear. Okay, next. Type null array. Okay, copy 2D. Kernel copy 2D. I separated on separate function just to make it clearer. Okay, let's just change index map to unsigned long. Unsigned long index map. Okay, index map, and add index width and index height. This is for later. Not end result width, index width. Passing full structure could create problems at some point. So just to keep things as clear as possible, I'm just going to pass the individual parameters rather than the full width, rather than the full structure. Index height, index map dot index data. So we don't need the index data. Just to keep things very, very clear. Index width. Okay, so now we know what we are passing. We're passing the index map as a two-dimensional structure, and the width and length, and the width and length of the source and result arrays. Okay, everything is, I think, good. Okay, index map, index width, no, index map dot index width, comma, index map dot index height, comma, index map dot index data, copy, index data. Okay, and then we make sure that everything's the right shape. Array the shape depth equals not equals source dot array to shape depth. It has to be the same length. Index map width equals same as parent length, and source length, that can be anything because the index map doesn't actually point into the shape of the source and the shape of the result don't have to be the same. Let's make sure everything's right. I should probably create a 3D copy of a 3D version of copy. We're gonna need it later, but no need to do that now. We're gonna create a lot more functions. Okay, now let's get into it. What was I? Matrix copy. Okay, everything's here. Index map copy. Let's just index map pooling. Now we create a version that calls for pooling, for average pool, index map pooling 2D. Okay, pooling is slightly different from scaling, just slightly different. Okay, and here we go for every single unit in the source image, and then we copy it into we copy it in the result image. But here we have to do something slightly different here. Index map if index if instead of summing everything up, no sum. Do we need sum? Yeah, we need sum. Instead of summing it up, we take the maximum. If absolute value, yeah, FABS. Do we have FABS? If the absolute value of source here, if the absolute value of source here is more than FABS sum, we need the maximum value. If the absolute value of the index is more than sum, we set sum equals source dot. Okay, so sum now equals the largest value. The max pool, no, is it average? I keep forgetting the name. Yeah, it's max pooling. We take the maximum value, the largest value. The maximum value is the largest value. Okay, when you do scaling from a larger image to a smaller one, the larger image is automatically divided into patches. Those patches are, the pixels in those patches are combined together and averaged together to make the final pixel in the result image. But here, instead of combining them, taking the average, we just take the maximum of them. The scaling algorithm, where is it? Index map scaling 2D, where is it? Index map scale 2D, scale 3D. It just takes each pixel and then averages the position, and then yeah, it combines the position of various pixels together to create those patches. We need a way to visualize this, but I don't have it. But anyway, it creates patches. So, and now we have the maximum value. Sum now equals the maximum value. Okay, that's the pulling to the forward, and then result equals sum. That's the first part. Pulling to the max, pulling forward. No, pulling to the forward or pulling to forward. Yeah, pulling to the forward. You have to be careful what you call this. You can already put it into the forward. Pulling to the forward. But there's also a reverse value. Pulling, unlike scaling, has a backpropagate version. Okay, everything else is exactly the same. All the parameters are exactly the same. Everything else is exactly the same. All of this is exactly the same. We don't need to change anything. Pulling to the forward, and that's it. But now we need to get in the other one. When doing pulling, we have to do a pulling backpropagation, which is slightly different. Okay, pulling reverse. Pulling to the reverse. Just a slight change. Okay, pulling to the reverse. Let's just change the names. Most of it is just exactly the same thing, but there are a few important differences. Okay, now at this stage here, we do the same again. Okay, sum equals, we take the sum. Okay, everything else is the same, but now we still need counter. We need counter again. Trying to remember what I did. Okay, counter. What should counter be? Counter. I call it counter, but I don't remember what it does. Counter equals. Yeah, counter equals. Oh, now we have to find out which one is the maximum. We're not trying to get the maximum. We're trying to figure out which one is the maximum. We don't need the maximum value. You just need to know which one's the maximum. Okay. Counter equal j. Okay, we go to all the pixels of the index, and we figure out which one of the pixels for that one is the maximum of the bunch. Okay, index height. It's a list of pixels. Okay, now I have to remember what I did. It's a list of pixels, and then we need to figure out which one's maximum. Counter is now the maximum index. But now we need to do a second thing, and I need to remember what it is. Oh, okay. Now we have to go through the same thing again. Went to it once to figure out which one's the maximum. Now we have to go to it again to figure out what to do with the maximum one. Okay, index. Just copy everything here. Oh, we have to copy this. K equals I. We need this. Why does it do that? Okay, so we do the same thing again, but this time we change something. Now I need to remember what I changed. If counter, no. Oh, there it is. If counter equal J, if this is the maximum, we go to each pixel one by one. If, why do we need to go to each pixel one by one? Oh, okay, because we have to do something with all of them. But what was it? Source. Okay, counter equal. I need to figure this out. Oh, now I remember. We're doing backwards. I completely forgot that we're doing backwards. Here we're going to all the pixels in the result of the pixel in the source to figure out which one what to do with it. We need to figure out which one's the maximum from the source, and then we instead of copying into the result, we just need to know which one we copy from the result into the source. That's what we're doing here, because the source has several pixels and the result has only one. The result has only one pixel. Well, assuming we didn't do it where the result is smaller. So the source has only one pixel, and the result the result has one pixel, and the source has multiple pixels. So we have to deal with all of them. Okay, so we go to all of them, and if counter equal J, we just copy it. Okay, result equals. There it is. Result equals source. If it's the largest, because here backpropagation is done immediately after feed forward, so all the pixels on the source are still the same. All the pixels. Oh, now I made another mistake, because the source is also the outputs, because we're copying deltas. Not deltas, outputs. Outputs. Okay. Now I remember. Oh, that was a mistake. Source should be replaced with outputs. Source is. Now I remember. That's a stupid mistake. Source is outputs. So we have three values here. The source and the outputs are exactly the same size. That's source here is the deltas of the source of the parent layer. Is the deltas of the parent layer, and the result is the deltas of the next layer. Okay, we're copying the deltas from the result into the source, but we can't copy all the deltas. We just need to copy one of them, and we use the outputs to figure out which one we are copying. Okay, so we find out which one is of the outputs is the largest one, not which one is of the source. Okay, we're assuming that the source and the outputs are exactly the same size. Not assuming, we actually have to check. Okay, source. What am I doing? Okay, I got this wrong. It's the reverse here. Okay, source dot resulted index equals result.I. Okay, so now we just copy. If it's the maximum, then we just copy it from result into source. Else, we set it. I will set it to 1 or 0. Yeah, we set it to 0. Okay, we set it to 0. So that's the complicated part. Okay, to do backpropagation in a pooling layer, we first take the outputs, the result of the feed forward operation, and then we go to all the pixels that make up that batch and figure out which one's the maximum, or actually the index of the maximum. We need to figure out which the index of the maximum, and then we take the deltas of the next layer, when the one with backpropagating, which is actually the source value, which is, since we do it backwards, we take the delta of the next layer and copy it into the specific value in the specific delta of this parent layer that made up the pixel that we took, because we only took one pixel, so you can only backpropagate one of them, and the others we do absolutely nothing. Okay, we only backpropagate one of them and then do nothing. Okay, is this correct? Well, it appears to be correct. Okay. Yeah, so that's it. Backpropagation. Find out which one is the maximum pixel, and then copy the delta for that one back into the. Okay, same here. We just figure out which one's the maximum and then copy it forward. Figure out which one's the maximum and then copy its corresponding delta into it. We're only updating that particular pixel. But here we have to add another array. Is it here? No. Here we add another array deltas, no, outputs. And another array outputs. Index map outputs. Pulling to the reverse, source, result, outputs. Same thing. If. Okay, one more thing. I should probably combine those, but it doesn't matter. Okay, parent.array, no, if shape compare, type shape compare. Okay, now I need to find shape again. So, okay, type shape compare. What was I? That neural array. Okay, we have to shape compare and parent.array shape. Not parent.array shape. Is source.array shape. Is it source? Yeah, source. Source.array shape. And where is it? And outputs.array shape. We assume they're exactly the same size and exactly the same shape. If they're not, then we have a problem. Is it outputs or output? No. Oh, and not output.array shape, and output.array shape. Okay, if shape compare, okay, we assume they have to be exactly the same shape. I should probably combine those if statements, but they look clearer that way, I think. I don't like the way they look, but they're easier to read. Okay, parents.array shape.array depth. Parents the result. Pulling to the reverse, pulling to the forward. Okay, now we have both functions here with a slight difference. Okay, now let us make a pooling layer. It shouldn't really do anything different, but just to be clear. Okay, where are we? Type neural network. Okay, now let's make us a pooling layer. Okay, layer null, and the ugly looking layer backwards. Okay, layer null, add layer. Scaling and pooling are identical. We just need to change the names. Add layer pooling. I just call it pooling. Okay, pooling is max pooling. Scaling is average scaling. Other than that, they are exactly the same. Pooling, create. I haven't made the function yet, but we'll make it later. It won't change anything. Okay, add layer pooling. Feed forward, everything's the same. We just add pooling wherever we see scaling. I personally prefer average pooling, but sometimes max pooling works. Max pooling works better, but I never use that. Pooling. Okay, let's just change everything. Whoa, whoa. Pulling feed forward. I'm gonna make it afterwards, so it doesn't matter. Okay, pulling. No, pulling. Pulling back propagate. Everything looks the same. No. Update weights only works on bias for now. And we add a pulling. Okay, pulling. Pulling destroy. Okay, we haven't added function yet, so now let's do that. Okay, go to definition and create a new file. New file. Come on. You can see I've never used that before. Okay, where is it? Let me check something. Okay, now I found it. Okay, let's just copy everything here into this new file here. Okay, now we're gonna change everything. Pulling. Okay, pulling. This is just housekeeping. Okay, pulling. Just copy and paste. Okay. Index map scaling. All of this should be the same. Pulling feed forward. Pulling destroy. Pulling back propagate. And let's just save it and we'll modify the function. Convolutional Neural Layer. Pulling. Come on, type neural layer. Pulling. Save. Okay. Now let's change a few things. Okay. Where are we? Not index map, node array. Okay, matrix forward, pulling forward. What? Counter. Do I have counter? Uninitialized variable. Oh, I made a mistake somewhere. I need to set counter to something else. It's not really a mistake. It's just that this thing is getting a bit. If counter equals j, counter equals 0. Counter equals 0. Okay, is this good? It's still not happy. Uninitialized memory counter. What? If counter equals j. Why is it not happy about it? That's just being weird. It's right there. Yeah, whatever. Anyway. Index map to pulling forward. Source result index map. Where are we? Pulling. Index map pulling forward. The outputs, the await index map 1. And then let's copy the next one. Index map. What am I doing? Where are we? No way. Index map to pulling reverse. Okay, all the functions should be in place. Pulling reverse. Pulling reverse, but now we need another one, which is parent result parent.layer deltas. Oh wait, do I have it right? Oh, I think I made a mistake somewhere. Oh, I think I made a mistake somewhere. Wait. Okay, I made a huge mistake somewhere. When doing forward, in the scaling part, it really doesn't matter. It really doesn't matter here. So because we're using the same function forward and backwards, we have to reverse this part. But with pulling, we're using two different functions, forward and backwards, which are the reverse of each other, which are the inverses of each other. So we don't change the order of everything here, because next, because the thing takes the next value, deltas. It takes the next value and then copy from the second one here. It copies from the second one into the first one, pulling reverse. We call it forward and reverse. So we have to keep all the parameters in the same order. This is something you need to be clear about, because that can get confusing. Whenever you see reverse, we keep everything in the same order when doing forward and backwards. They're outputs. Now we change that to outputs. Bind.layer outputs. Okay, so should it work? I want to know if it works because wait a minute. Oh, whoa. Oh, index map 1. Because the pulling operation uses the same index map. Because that way we don't need a second one here. Okay, source result. Result next. That can get confusing, shouldn't it? I don't remember why I put result first and after source. Oh, that's something to remember. I was trying to be clear, but I think I just confused myself. Okay, they both use the same index map. Okay, everything's set to 0, isn't it? Yeah, neural layer set everything to 0, so we don't need to worry about details like that. Okay, pulling forward, pulling reverse. Okay, the problem is that it doesn't actually do anything. Pulling reverse, pulling forward, pulling back propagate. Okay, it just uses one of the scaling variables. Assign, pulling, neural layer create, go to the definition, yeah. And then we add pulling to the list. Add pulling to the list, and everything should be right. I'm going to compile, see if there's any mistakes. Okay, no mistakes so far. Pulling doesn't work the same as scaling, so we shouldn't be seeing anything really different. But let's see what it does anyway. No, scaling. Because pulling only works for shrinking images. That's the thing about average scaling. When you do when you're going up, when we're taking a small image and making it bigger, we need scaling. Pulling doesn't work here. If we is pulling here, things will go completely wrong. Pulling is when we're going from a large image to a smaller one. It only works there. Okay, build, rebuild. Okay, and run. Oh, it does something. Unless I made a mistake somewhere, but it seemed to do something. It just blurs the image. It just takes the maximum value, and then actually it does the same as scaling. It just takes the maximum value, and then yeah, it works. That's what I mean when you say pulling. It divides the image into patches. That's what you can see it here. It divides the image into patches. Each pixel is a patch of pixels. Is a patch of pixels that is shrunk into a single pixel. And when we do the reverse, it takes that single pixel and then blows it up into several pixels. So it works. Surprisingly enough, it works. Usually I get errors here, but this time it worked. Now I'm going to do some housekeeping. Okay, all these functions here, make sure that they line up, because it's important to encapsulate everything. We have the structure, and then we have all the functions that operate on it. Scale to the convolution output, convolution transpose, data. I think I have everything here, and then neural network. I think I missed a few things here in neural network. Okay, let me see what they are. Create, add layer. That's internal, static. That's what I call it, static. Add layer null, and then add layer bias. We need to remember that. Just copy add layer null. Add layer bias. Add layer scaling. Let's see. Add layer scaling. Yeah, it's not gonna behave. Yeah, I can't copy this. Okay. Add layer scaling. Oh, that looks bad. I'm just going to extend it all till the end of. It makes it hard to read, but I don't care. Okay, let's just extend everything all the way over here. Hard to read, and then scaling and pulling. It should be exactly the same, I think, unless we missed something. Let's check something else. Okay, while cleaning up the code, I realized I made a giant mistake here. The problem is right here. It's actually right here in this multiplication right here. It's not obvious what it is, but it's really stupid. You're not supposed to divide by the result array. Where am I? You're not supposed to divide by the result array. You're supposed to divide by the maximum. When you do scaling, because sometimes scaling is from smaller to larger and from larger to smaller. So you can't just do it one way. This is one of those mistakes that's really hard to spot unless you really know what to look for. Okay, scale. Okay, X result. Okay, unsigned long. Is it unsigned long or is it long? Yeah, unsigned long. Okay, unsigned long. XM, X max. YM, ZM. Okay, maximum. Okay, XM equals the maximum. Is it max? Max. Okay, I always had a lot of trouble with this. Let me just create my own max function, because every time I've tried the max thing, it always gives me a mistake. Okay, type math. Why is there so few things here? Okay, type sign. Am I in the right place? Okay, type math. Open contain folder. Yep, type math. Oh, you have to copy more things here. Type math. Type max. Max if A more than B. We need a B. What's a B? If A more than B. If A equals more than B, return A. Else return B. Return B. And that's it. Okay, let's use that. Okay, index map. That max. Okay, max source length, source width. What am I? Source width times. I just copied the whole thing. I don't feel like copying this here. Okay, XM, YM, ZM equals that max. That max shape width, zip height. Okay, copy this. Am I in the right place? Yeah, I think. Oh. Mask shape width. Okay, copy and copy. Okay, it should work. Okay, that max. Okay, so now we need to do the division, all these operations here. So X value scaling is we have to do two of them. Oh, now I remember. Wiki. Okay, we have to do two of, because we have to count from the maximum one. Okay, is it ZM? J the reason we're doing this because again we don't know which if we're doing from maximum from small to larger or from larger to smaller. So we need to make sure we have everything right. Because if we're doing from larger to smaller, there are more pixels to count. So the total number of pixels must be the larger one because we need to consider every single pixel, not just the result ones. So this part right here, result, if for I equals 0 to result, with that simply cannot work. We have to count every pixel, no matter how big it is, big or small it is. Okay, xm. Okay, we need x result and then x source. XR, XR, YR for Y result, Z result. XS for X source, Y source, Z source. Okay, so X result equals IJ result at array weight, no, not that, result divided by XM, not X maximum, result divided by maximum, XM YM ZM. Okay, so now we take the, I remember why I did it like that, XR, no, XR YR ZR. Again, we have to consider every single pixel, whether it's from the source of or from the result. Everything has to be the same. Now we do the same thing for source. It seems rather simple, but it's not. Okay, everything's the same. X source, Y source, Z source. Everything else is still the same. No, let's change that. XS, no, YS, ZS. Okay. Because once again, we have to consider every single pixel, no matter which one is, whether it's from source or from the result. Okay, so we have to know everything. So let's just copy this down here, and just copy this from in the 3D version. And next map create 2D. Let's just put 2D before 3D because it's 2. Okay, so get rid of the Z values. I and J, get rid of K. Instead of shape length is result path equals result, no, result dot shape width. Result dot shape width, no, shape width times result dot shape height. The size of the next map is the same. Wait a minute, am I missing something? Okay, if the index map is not the right size, then something will just go wrong. Okay, let's just get rid of this. Let's set this to 0. We just set everything to 0. And that's about it. XS, YS, ZS, IJ, edit, advance, format document, put everything in the right place, and it should be right. Okay, XM, YM, ZM. I'm going to compile it, make sure I didn't make any other mistakes. Okay, I've compiled. The only mistake was it was complaining that type max was returning a double value, so I just cast it to unsigned long. But unless I miss another really stupid mistake, that should be it. Oh, and one more thing. When we're doing the pooling, something happens. We can see it here. It's not really visible here, but anyway, it's not really visible what it is, but index height is now 99. So as we combine them from what was it? From image width, whatever it is, down to image width is 178, down to 20, from 178 to 20. That puts 99 pixels in. It combines 99 pixels into one. Where was I? Yeah, the index height combines 99 different pixels into just one pixel. So when we do the loop here, when we're looping from here to there, we have to loop 99 times to find out which one's the maximum. But regardless, it works. Okay, and one more thing. You see that the pooling looks really, really strange. That's because it's only considering the maximum value. But if we do scaling, it's going to look slightly different. Scaling. Let's just name it scaling, and then we build. Okay, you can see the difference here. It's still pixely, but the pixels correspond more to the right color. So pooling and scaling are different. Like I said, everything else is still exactly the same. Pooling and scaling are basically exactly the same, except for one you could taking the maximum value, and the other you're taking the average value. So at least it works. We still need to do some housekeeping, but I'm going to do that in the background. That's pretty much it for today.